So, you've learned properties of parallelograms, and we're going to put this to use and summarize what you know, and we'll see how that comes together so that you can write a proof. So first we're going to write two congruent statements about this parallelogram PQRS. What information was given and how do you write a congruent statement? We're going to be looking at the tick marks. Might as well start with the single ones. That would be section PQ, segment or side PQ. So I'm going to write PQ with a line over it. Make a congruence symbol, statement, and I'm going to say that it's congruent to SR with the line over it. What else do I know that's congruent? I know the other segments are congruent, so I'm going to write that as being PS is congruent to QR. Right? That's what you'd expect. Are the congruent sides opposite or consecutive? Opposite or consecutive? Well, they're opposite. And that's part of the definition of parallelogram. So we want to keep that in mind. So write two congruent statements about this parallelogram. What information are we given? It's information about the angles. And what angles have the same symbols? That would be angle D, I'm going to read from left to right, is congruent to angle B, and angle A is congruent to angle C. And that fits the definition of parallelogram because they're opposite each other and they're congruent. And that's what we want. They are opposite. But what do we know about consecutive angles? Consecutive angles are supplementary. Supplementary. And what number is used with that? Supplementary. (180 degrees). They have to add up to that. But you've been keeping up with this, so you already knew that. Okay, how do we name the diagonals of this parallelogram? Well, we name it by the two endpoints, the two letters. That would be AC, and the other diagonal is DB. We are not going to say that they're congruent, not right now, and they're not labeled as being congruent. What does M stand for? The midpoint. So it means that it bisects on this diagonal and it bisects on the other diagonal. How do we know that they're actually bisecting? Okay, well, first of all, I could say it's by definition of a parallelogram. And that's something that you learned. It's one of the properties. But we could think a little bit more about what is really taking place. If opposite sides of the parallelogram are the same length, or if they're congruent, all right, then where that ends here and here, and where that ends here and here, the distance across is going to be the same. And when it crosses on the diagonal, it bisects. That line didn't bisect very well. You want to clear that up. Let's move on. Let's get a little more interesting. You're going to decide whether or not you've been given enough information to determine that a quadrilateral is actually a parallelogram. So we need you to draw a picture for each example. Here we go. That opposite sides are parallel. Opposite sides are parallel. Okay, those are opposite sides are parallel. If I have opposites, I have to have 4, 2 on each side, and that would be a parallelogram. It could look a little different. Okay, so I could have these sides be parallel, but this side is a different length maybe. I think we could say that that's would fit the bill for a parallelogram. Let's go to the next one. If at the opposite sides are congruent, opposite sides are congruent. Okay, that's that. This is this. Looks like a parallelogram. I don't know if you were able to draw something that defeats that definition. What about two pairs of consecutive sides being congruent? Two pairs of consecutive sides. Now, how many do we need to have for a pair? Okay, this would be a pair, consecutive, congruent, congruent. And then another pair being congruent. Like an isosceles triangle. Let me try that again. If I draw an isosceles triangle like that, well, it's looking like a kite, which means it's not necessarily a parallelogram because the sides, the opposite sides, are not parallel. Two pairs of consecutive angles are congruent. Okay, I'm going to do a 90 because that's easy to see. That's one pair of consecutives. That would be another one. Yep, that's enough information for me. Clear. Go to the next one. Diagonals are congruent. This is getting predictable. Diagonals are congruent. That's a parallelogram. What about diagonals that bisect each other? And when diagonals bisect each other, that means you have a rectangle. Now this is pretty obvious. All four sides are congruent. By definition, that's a square if it looks like that, or we're going to find out what it's called when it looks like that, when all four sides are congruent. Turns out they're still parallel. And last but not least, consecutive angles that are supplementary. So let's say we have 50 and 130, and then that would be by definition the parallelogram. So that's a summary. It's what you've learned. We're going to be using that for writing proofs. Very good.